Welcome back, math friends. Today we are taking a look at topic 1, block 4 in ratios and rates, and we're looking at a different kind of scale factor. Now, we've been talking about scale factor as just, scale factor is scale factor, but there are actually two types of scale factor. The first type is what we've been learning about, and that first type is linear scale factor. And that linear scale factor is the factor, remember factor is something that you multiply, the factor that changes the length of the dimensions between two objects. So it changes either the length or the width or the height by multiplying by that factor. So that's linear scale factor. But there's a different type we're going to talk about today called area scale factor. An area scale factor, it's still a factor, so it's something that's being multiplied, but it's the factor that changes the size of the space that is occupied between two objects. So it's the space that the two objects take up. So make sure you write those definitions down, linear scale factor and area scale factor, in your notes. And then after you do that, draw a nice line underneath there before we move on to the next piece. We're going to be looking at these two rectangles here. We have a rectangle that measures 3 inches by 4 inches, and then it changes to 6 inches and 8 inches. Let's take a look at the linear scale factor between those two shapes. And if you remember, to find linear scale factor, we are going to we're going to divide the new dimension by the original dimension. Okay, because that's going to give you a scale factor every time. So let's look at the linear scale factor between these two. Now we are going from the small rectangle to the large rectangle. And so that makes this the new one, or the copy, and this one is the original. So to find the linear scale factor, we are going to divide. I'm going to divide the width of this one by the width of the original. 8 divided by 4, and 8 divided by 4 is 2. So this has a scale factor of 2. Now, of course, I could have I'm stuck on that. We could have divided the 6 by the 3. 6 divided by 3, I'm still going to get 2 for my linear scale factor. And that means that the new rectangle is 2 times higher and 2 times wider than the original rectangle. All right, but how does that compare to the area scale factor? Well, to do that, first of all, we have to find out what the area of each rectangle is. So remember, for a rectangle, the area formula is length times width. And in this case, our length is 3, the width is 4. So that's going to give us a rectangle with an area of 12 square inches. Remember, area is in square units. Well, what's the area of our new rectangle? The area formula is still the same. It's still going to be length times width. The length is 6, the width is 8, and 6 times 8 is 48. 48 square inches. Now, let's compare the areas. We're going to find the area scale factor. Now, the formula is still the same. It's new divided by the original. So what is the area of the new rectangle? The area of the new rectangle is 48. And the area of the original rectangle was 12. We divide those. 48 divided by 12, and that gives us 4. So it has an area scale factor. Area scale factor of 4. That's very interesting. We'll come back and take a look at that in a few minutes. Let's go to the next set of shapes. Now it looks like we have the same rectangle for the original, but our new, or the copy, has a different set of dimensions. Now we're going to find the linear scale factor of this one. Remember, it's new divided by original equals the scale factor. So let's take a look at 12 divided by 4. Those are the corresponding dimensions. 12 divided by 4 is 3. So it has a scale factor of 3. Could we have divided 9 by 3 and gotten the same thing? 9 is the length. 3 is the other length of the original. 9 divided by 3 is 3. So yes, the scale factor is 3. But now let's take a look at the areas. Remember, area is length times width. So the area of this one would be 3 times 4. We know this is already, it's 12 square inches. But what's the area of our larger triangle? The area is going to be length 9 times the width 12. 9 times 12 is 108. That's 108 square inches. Now let's compare our areas so we can find the area scale factor. The new area is 108. The original area was 12. 108 divided by 12 is 9. So we have an area scale factor of 9. 9, area scale factor. Area scale factor of 9. Okay, pretty interesting. Pretty interesting. For now, let's go on to the next set of shapes. Oh, here we've got some triangles. And one is proportional to the other. And so we are going to use the same thing. We're going to find the linear scale factor. And so, of course, we're going to divide the new dimension by the original dimension. New divided by original equals the scale factor. Okay? So, 15, because this is our new triangle. Here's our original triangle. The base of that triangle is 15, divided by the base of the original triangle was 3. 15 divided by 3 is 5. Okay. What about the height of the triangle? Is it the same? Let's see. That's 10 divided by 2. New divided by original. 10 divided by 2 is 5. So the scale factor to increase the length of the sides is 5. Okay, well, let's see what our area scale factor is going to be. Now, the area of a triangle is a little bit different. Remember, it's base times height divided by 2. Our base is 3. Our height is 2. Divide that by 2. 3 times 2 is 6. 6 divided by 2. 6 divided by 2 is 3. So the area of this triangle is 3 square centimeters. What about the area of the new triangle? Well, that's still going to be the same. The base, which is 15, times the height, which is 10, divide that by 2. 15 times 10 is 150, divided by 2. 150 divided by 2 is 75. So the area of the larger triangle is 75 square centimeters. Well, now let's see what the area scale factor is between those two. We're going to divide the new area, which is 75, by the original area, which was 3. And 75 divided by 3 happens to be 25. So the area scale factor is 25. Okay, so now we have found the linear scale factor of three different shapes when they change sizes, and we found the area scale factor. That's going to bring us to our next question. Make sure you write this question down in your notes. The question is, what is the relationship between a linear scale factor and area scale factor? Well, that's a great question. Let's go back and take a look at the three different scale factors that we've had, the linear versus the area scale factor. The linear scale factor of our first one was 2. The area scale factor was 4. And I want you to see that if we take the linear scale factor, which is 2, and we square it, that's going to give us 4, which is the area scale factor. So if we take whatever the linear scale factor is and square it, it's going to equal the area scale factor, because 2 squared is 4. Linear scale factor squared equals the area scale factor. Does it hold true every time? Well, let's see. Our next figure was the rectangle, but in this case, the linear scale factor was 3, the area scale factor was 9. 3 squared, 3 times 3, equals 9. So again, in this case, the linear scale factor, if we square it, is going to equal the area scale factor. It happened again. We squared the linear scale factor to get the area scale factor. Interesting. Yes? Is it the same with the triangle? Let's find out. The linear scale factor of the triangle was 5. The area scale factor was 25. 5 squared equals 25. 5 times 5 is 25. So in this case, the linear scale factor, when we squared it, equaled the area scale factor. 5 squared is 25. Interesting relationship. So what is the relationship between the linear scale factor and area scale factor? Let's answer that really quickly here. To find the area scale factor, it looks like all you have to do is multiply the linear scale factor by itself, or square it. So to find the area scale factor, you square the linear scale factor. Put simply, the linear scale factor, LSF, squared will equal the area scale factor. So the area scale factor is increased by whatever the linear scale factor is squared. It takes up that much more space. Let's see if it works when we size down a figure. This is a square, and so remember, to find the area of a square, it's a little bit different. Remember, the area of a square is equal to the side length squared. Area is the side length squared. But before we do that, let's remember we're going to find the linear scale factor first. The linear scale factor, this is going to be our new square. This is our original. So the side length of the new one is 2. The side length of the original is 8. 2 over 8. We need to simplify this fraction because we know that the scale factor, because it's getting smaller, is going to be somewhere between 0 and 1. If we divide both of these, the numerator and the denominator of this fraction, by the greatest common factor of 2, we will get the linear scale factor of 1/4. Linear scale factor of 1/4. What should the area scale factor be? We should be able to figure that out at this point. Remember, the area scale factor is equal to the linear scale factor squared. What's the linear scale factor? Well, it's 1/4. So 1/4 squared is going to equal the area scale factor. 1/4 squared is 1/4 times 1/4. And when we multiply straight across, we get 1 times 1 is 1, 4 times 4 is 16. So the area scale factor is 1/16. That means that the smaller square takes up 1/16 less space than the original square. Let's see if this is true. The area of our first square is the side length squared. That's going to be 8 times itself. That's 8 times 8, and 8 times 8 is 64. The area of the small square, the side length is 2, so that's 2 squared. That's 2 times 2. 2 times 2 is 4. All right, now let's find the area scale factor the old way. We're going to divide the new by the original, the new area divided by the original area, 4 over 64. I can divide both of these by the greatest common factor of 4, and I get 1 over 64 divided by 4 is 16. So that worked. We did it the old-fashioned way by dividing new by original. And we got 4 over 64, which equals 1/16, which we already found that by just squaring the linear scale factor. That's pretty fantastic. So if that's the case, it should work for any time. If we want to find the area scale factor, all we really have to do is find the linear scale factor and square it. Let's test it here on this next one. Now here we've got a couple of diamonds. Ooh, very nice, very nice. Let's find the linear scale factor first. So the linear scale factor, we have to find that. And that's going to be, remember, new divided by original. So we are going from the large to the small. So that means we are looking at 5 over 10. We need to simplify that. We can divide both of these numbers by 5 to simplify it. 5 divided by 5 is 1, 10 divided by 5 is 2. So the linear scale factor is 1/2. That means that the diamond on the right is half the height of the diamond on the left. But what about the area? How much will the area change? Well, remember, area scale factor is just the linear scale factor squared. So that's 1/2 squared. That means that's 1/2 times 1/2, and that's 1/4. So what does that tell us? Well, that tells us that the area of the small diamond is 1/4 the size of the area of the large diamond. So if you want to find the area scale factor, area scale factor, if you want to find that, you take the linear scale factor and square that thing, and then you'll find the area scale factor. Pretty great stuff. All right, that's all I have for you today. Have a great rest of your day, and don't forget to be awesome. See you next time.